Hi, welcome back. Hope you're having a wonderful day. In the previous lesson, we learned some key properties of rational functions. We learned how to look at equations and determine some of the key properties. Today we're going to build on that. We're going to take that idea and we're now going to translate that into sketching the graph of a rational function. So here are the steps we're going to be using to try and sketch the graph of a given rational function. We're going to first identify all the non-permissible values. We're going to write the equations of any horizontal or oblique asymptotes. We're going to identify any vertical asymptotes or holes. We're then going to look at the behavior of the graph near those asymptotes. We're going to identify some of the key intercepts and then connect the dots by completing a table of values. Alright, let's give this a try. So our first example here requires us to sketch that graph. Our first step is going to be to factor that, see if we have any holes or vertical asymptotes. So when you factor that out, your factors are going to look like this. The top part's going to be x minus 4 and x plus 3, and the bottom part's going to be 4 minus x. From looking at it, it doesn't appear we have a common factor. However, if we rearrange the bottom factor, we end up with something that looks like that: x minus 4, x plus 3, and the bottom is actually negative of x minus 4. From that form, we do notice that, hey, x minus 4 is a common factor. Therefore, we have a hole at x equals 4. And furthermore, I'm going to find the coordinate of that hole. That hole is going to happen at 4, comma. I plug in x equals negative 4 into the top part of that expression. I'm going to get 4 plus 3 is 7, divided by a negative is negative 7. So 4 negative 7 is where that hole is going to be. Now, in case you're wondering where I got that negative 7 from, I'm actually looking at the reduced form of our expression on the side here. If I reduce that out, what I'm going to be left with is simply a negative of x plus 3, which is a linear function. So I know that at the end of it, what I'm going to get is a linear function represented by that equation with a hole in it. That's the kind of graph I'm getting over here, which tells me the next thing, that I no longer have any horizontal or oblique asymptotes. So no horizontal or oblique asymptotes. And again, I know that because the reduced form is just a linear function. I've got the holes, I've got the fact there's no horizontal or oblique asymptote. Next is I need to figure out the intercepts. So find the intercepts. Well, just from looking at that equation, I know that the y-intercept is negative 3. So I know that y-intercept of that equation is going to be at negative 3. So I'm going to have a point at negative 3. For the x-intercept, I simply plug in y equals 0 and solve for x. Plugging in y equals 0, solving for x, I will do that to the original equation up there. Actually, it really wouldn't make a difference because the reduced form is going to give me the same thing. Plugging in y equals 0, solving for x, I get 0 equals negative x minus 3, 3 equals negative x, x equals negative 3. So I have an x-intercept at negative 3. So x-intercept at negative 3. This will tell me what that graph's going to look like. I also have a hole at 4 negative 7. So at 4 negative 7 down here, I'm going to draw a hole. There's going to be a hole over here. Now it's just a matter of me connecting the dots and coming up with my graph. And this is what the graph will end up looking like once you have connected the dots. Let's try one more example over here. In this particular example, we're working with the following function: negative 2x squared over x squared minus 25. So our first step is to go ahead and factor that out. When we factor that, we're going to end up with negative 2x squared over x plus 5 and x minus 5. Once we've got the factored form, we will recognize that there are no common factors, so we're not going to have any holes this time. However, we do have two non-permissible values, and both non-permissible values are going to represent vertical asymptotes. So as a result, we have vertical asymptotes at x equals plus or minus 5. Next item, I look for horizontal asymptotes. Because both the functions top and bottom are degree 2, I do have a horizontal asymptote, and in fact the horizontal asymptote is going to happen at y equals negative 2. So we have a horizontal asymptote at y equals negative 2. Again, that's coming from the leading coefficients here and here. Now before I do anything else, I'm going to go ahead and plot these asymptotes on my graph, and once I've got those down, I'll look at the next step. So once I have drawn those asymptotes, I can now take a look at making a table of values to examine the end behavior of the graph around the asymptotes. What that means is I want to figure out how the graph is behaving around those asymptotes. So some of the key values that I'm going to pick are as follows. I'm going to start off by a number that's really big negative, so I know what's happening in that region, so I'll pick negative 100. I also want to pick a number really big positive, so I'll pick positive 100. Now I want to test the values around the asymptote. My asymptote is at negative 5. I want to see what's happening with the graph directly to the left of negative 5, so I'll pick negative 5.01. And I also want to see what's happening directly to the right of that asymptote, so I'll pick negative 4.99. Similarly, I'll pick the other asymptote. The point right before that asymptote of positive 5 is 4.99, so I'll pick that. And positive 5.01, I'll pick that. I'm going to calculate the y values for those points. You can take a moment to do that. Hopefully these are the points that you came up with once you plug them into your calculator. Let's put these on the graph now. So on the graph, let's see what's going to happen. When x is a really big negative number, we're going to be at negative 2.005. So what that's telling us is when x is a really big negative number, we're going to be just below that asymptote. So really close to the asymptote, but just below it, somewhere around there. When x is positive 100, we're going to be in the same sort of locations. We're going to be below that asymptote. At negative 5.01, I'm to the left of that asymptote. I'm going to be a really big negative number. I'm going to be on this side here, somewhere along the way. This is telling me that my graph is sort of in this region right here. Similarly, at negative 4.99, I'm at a really big positive number, so I'm going to be up here. At positive 4.99, I'm a really big number. I'm going to be up here. At positive 5.01, I'm going to be a really big negative number, so to the right of that, I'm going to be down here. So just by looking at these points, I know that I'm going to have a graph in this region right here. I'm also going to have a graph in this region right here, and I'm also going to have a graph somewhere in this region right here. Okay, so let's fill those gaps in. The next thing I need is to find the intercepts, put those on the graph, so let me look for that. So find the intercepts. X-intercept means y equals 0, so x-intercept means y equals 0. You take that expression, you plug in y equals 0, so what you're going to get is the following. 0 equals negative 2x squared over that expression, x squared minus 25, which means 0 equals negative 2x squared, which means x equals 0. So that means we have an intercept at 0, 0. When y is 0, x is 0, that means when x is 0, y is also 0. So we only have one intercept here, and that's going to be at the point 0, 0. So as a result, I'm going to plot that over here. This is the point that I'm going to be working with, 0, 0. I have no other intercepts. I still don't have enough information to complete that graph. So my last step that I'm going to do is I'm going to fill in the gaps by making a table of values using some other values. So my last step here is fill in the gaps by picking some other values. No, I just don't want to pick any random values. I want to strategically pick values in each of the regions that I'm working with to give me some information about the behavior of that graph. I don't want to have 20 extra values and have a really big table of values. So let me see what's the bare minimum that I need on this graph. Well, I need to know what's happening in this region over here. So in that particular region, I'll pick another point. I'll pick, say, x equals -7 and see what I get for that. Then I want to find out what's happening in the middle region there, so I can pick one value on each side. I can pick a value here, I can pick a value here. Let's say +3 and -3. So I'll pick that, -3, +3. And finally, I want to know what's happening in this region right here. I can pick a value in there, and I'll pick, say, +7. Right? You want to pick just enough so you get enough information about the behavior of that graph. Plug those into your calculator, see what you come up with. So once I plug them into my calculator, the values I came up with are as follows: -7, -4.1, -3, 1.1, 3, 1.1, and 7, -4.1. Now it's just a matter of me putting these on the graph and connecting the dots. So let's see what our graph is going to end up like. Okay, so we have -7, -4.1. So -7, -4.1 is going to be a value somewhere over here, which means on this side the graph is going to be behaving in this manner right here. It's going to be asymptotic. The next point that I have is -3, 1.1. So -3 and 1.1 will be somewhere up here. +3 and 1.1 will be a value up here. So in this region the graph is doing something like this. It's a sort of like a parabola. Okay, let me redraw that one here, so that way we're a bit better off. Okay, it's going to do that. And then in the last region over there, 7 and -4.1. Point here again, it's going to be sort of an image of the other side. It's going to be doing something like this, right? So this is the graph, and again, if you weren't sure of the shape of that graph, then you would just pick a few more points nearby and try and connect that graph. But that's the general shape of that function. This is what it's going to end up looking like with the asymptotes and those intercepts. There we go. We have the graph of that rational function. Let's try another example, something that looks a little bit different. So our next example here is the following. I will give you a moment to go ahead and do the first few steps. Try that on your own. We will compare our answer. So pause the video here, give that a try, come back and compare your answers with me. Good luck. So once you've had a chance to give this a try, this is what you're going to end up with. My first step is to go ahead and factor that polynomial. When I get the factored form, this is what it's going to look like. From this factored form, I can recognize that I have vertical asymptotes at x equals ±2. So I'm going to go ahead and first graph those vertical asymptotes. I end up getting a vertical asymptote at -2 and at +2. I also have a horizontal asymptote at y equals 0. I know this because the degree of the numerator is 1 less than the degree of the denominator. As a result, I know that I have a standard horizontal asymptote at y equals 0. I'll go ahead and graph that with the dotted line there. My next step is to figure out some key values that determine the end behavior around the asymptotes. So for that, I picked the following key values. I haven't plugged them in yet because I want you to go ahead and give them a try. Now the reason why I picked these values is because I want a really big negative number, a really big positive number. I picked -10 in this time. I also want values directly beside the asymptotes. Since the asymptote's at -2, I picked -2.01 to the left of it and -1.99 to the right of it. Okay, those two values. Also, the second asymptote is +2. I picked the value really right before it, which is 1.99, and one right after it, 2.01. So I got those values. So I'm going to go ahead and plug those numbers into my calculator, see what I come up with, and then graph this function. What I also want you to do in this point in time is not only plug in those values, but also discuss the intercept, figure out if there are any x or y intercept. And finally, the last step is to fill in the gaps by picking some other important numbers. Give this a try, pause the video, and then we'll check our answers one more time. So this is the table of values that I came up with. Those are the values that you get once you plug it into your calculator. I also worked out the x and the y intercept. Well, the y-intercept is going to happen when x is 0, so you plug in x equals 0 into the equation, and what you end up getting is actually one single intercept at 0, 0. So it's the same x-intercept as it is the y-intercept. I'm going to take those points and I'm going to go ahead and plot them onto my graph. So let me go back up over here. Let me load up my graph right here. Okay, on this graph I'm going to go ahead and plug those points. So you've got the points in front of you. The points I have are -10, 0.625. So at -10, I'm going to have a value at 0.625, so roughly up here. At -2.01, I am 300, so -2.01 here, I'm a really big value, so I'll just put it right beside +10 here, and I'm going to be up in that region. At -1.99, to the right of that asymptote, I'm going to be a negative big number, so -2.99, so number down here. At +1.99, I have a really big positive number, so I'm going to be up here to the left of that asymptote. And to the right of that asymptote, I'm going to be a really big negative number, so a point down here. And then lastly, +10 was -0.625, so +10 is -0.625, so a point down here. So I've got these points figured out. Now I need to fill in the gaps. Actually, I've also missed the intercept. The intercept was at 0, 0. Now this might appear to be a bit strange because we have a horizontal asymptote, yet we also have an x-intercept at that point. And we're going to talk a little bit about that in just a moment once we have an idea of what this graph looks like. This is a unique case. I want to fill the gap, so I picked some other key values. I picked the following key values. I picked -4, -1, +1, +4. I picked those specific values. So -4 will give me something in this region right here. +1 and -1 will give me something in this region. And the +4 may tell me something about this region of the graph as well. Okay, so I want to know what's happening in each of those regions of the graph. So the values I end up getting are -4, -2, -1, sorry, -4, +2. So -4, +2. I also get -1, -2 down here. I also get +1, +2 up here. +4, -2. Now it's a matter of connecting the graph. I start off with the leftmost point. I look at these points. This graph is going to be connected from this point to this point and behaving asymptotically by connecting to that point. Right, so this portion of the graph looks like that. The next portion of the graph sort of does a dance. It starts off at the bottom here. It's like a cubic function. It's going to go all the way up. It's going to touch that point, pass through those points, and behave asymptotically by passing through that point. Okay, so that's the graph that I get from that side. And then lastly, on the very right side, if I connect the dots, I get the following function. So this is the general shape of the graph that we're going to be getting. And one of the things you'll notice is that even though our graph is behaving asymptotically with the horizontal asymptote for most of the graph, there is a portion in the middle of the graph here where it's not behaving asymptotically. And this is a unique case that does happen once in a while depending on the function. And the graph does cross over that horizontal asymptote, but the general shape makes sense because it's a connected graph. This is the graph of this function. Looks a little different, but still makes sense. Let's have you try one more example. Okay, so let's move on to our next example. Our next example here is to sketch the following. Again, the same process. I will let you go ahead, give that a try. Once you've had a chance to try it, you can unpause this video and look at the solution. This time I'll have the full solution worked out, and you can just match up and see if your graph matches up with my graph. Good luck. Okay, so one of the first things hopefully you noticed is that this polynomial at the top does not actually factor. What that means is it does not have any common factors with the polynomial at the bottom, which means we know that we are not going to have any holes in it. What we do have still is we still have a non-permissible value at x equals 2. So as a result, we're going to have a vertical asymptote at x equals 2. One of the other things you'll notice is that the degree of the numerator is 1 more than the degree of the denominator. So as a result, we have an oblique asymptote. And to find the oblique asymptote, we again go ahead and do our synthetic division. Okay, so go ahead, do your synthetic division, and you're going to end up with this expression right here. You're going to get y equals 2x minus 1 plus 3 over x minus 2. As a result, I can say as x goes to infinity, this expression over here is going to approach 0, which means my equation of the asymptote is simply going to be the part that's left over, y equals 2x minus 1. What I'm going to do next is I'm going to go ahead and plot both these vertical asymptotes and the oblique asymptote onto my graph. So let me show you how I did that. I went back up to my graph. I have plotted over here the vertical asymptote and the oblique asymptote. So the vertical asymptote is simply x equals 2. That's that line right there. The oblique asymptote has the equation 2x minus 1, so you got to think back to grade 10 when you learn how to graph a linear function. Y-intercept's -1, slope is 2, so y-intercept -1, slope is 2, rise over run. Those are all the dots. Those dots are going to make an oblique asymptote. That's the equation of the oblique asymptote. Next up, we've got to figure out if there's any intercepts on this function. So I'm going to scroll down over here, and I try to figure out if there are any x or y intercepts. So the easy part was that I figured out there is a y-intercept. Y-intercept happens when x is 0. So I'll go ahead and plug in x equals 0 here. I solve that equation, I get the point x is 0, y is -2.5. So as a result, I have this point on my graph, 0, -2.5. I also need to see if there is any x-intercept. Because it's not the same, there's going to be a different possible point. For the x-intercept, I plug in y equals 0, substitute into my expression, and I get this. Now, the problem is, because this expression here was non-factorable, I can't just easily factor it and look for the roots. As a result, I have to use the quadratic formula to try and figure out if there are any, in fact, roots for that expression. There might be, or there might not be. So let me plug the numbers in. I use the quadratic formula. Minus b plus or minus b squared minus 4ac over 2a. I plug in the values, and what I'll get is the following. I'll end up getting this expression over here. Now what this expression is telling us is that we're taking the square root of a negative number. As a result, we know that that is not possible, or in fact, it's not going to give us any real roots. Okay, so we have no real roots. What that means is there are no x-intercepts, right? So as a result, there are no x-intercepts. Once we know that I have no x-intercepts, but I do have a y-intercept, I can go ahead and plot that. My y-intercept was at 0, -2.5. So I'm going to have a point right here. I don't have any x-intercept, so the graph's not going to cross the x-axis. Now I need some other key points to go ahead and fill in my graph. So some of the key values I will test are as follows. I'll pick -10 and 10 because I want to see what's happening along really big and really big negative values. And when I plug them in, I'll get -10 will yield -21.25. +10 will give me 19.375. So at -10, the value is really off the chart. I'm not going to worry about that. At +10, the value is also off the chart at the top over here. I'm not going to worry about that. I'll look at these values here, right before the asymptote, right after the asymptote. 1.99 tells me I get a value of negative 297. So I know that just before the left of the graph, I'm at a really big negative number. So I'm going to be down over here on this side, right before the graph. To the right of the graph, at 2.01, I'm going to have a value of 303. So I'm going to be a really big positive value. So to the right of that asymptote, going to be a really big positive value. I said graph, sorry, I meant the asymptote. To the right of the asymptote, I'm going to have a really big positive value. That still isn't enough to give me enough points to make a graph. So what I'm going to do instead is pick some other key points. So let me pick some points that I do visually see. I want to see what happens when, say, x is negative 2. So I can pick a point negative 2. When I plug that into my equation, I will come up with the y value of negative 5.75. So when x is negative 2, y value is negative 5.75. I'm going to get a point right here. I'll pick negative 1, x is negative 1. Actually, let's pick positive 1. When x is positive 1, I get a y value of negative 2. Positive 1, y value of negative 2. So what this is telling me is that my graph is going to behave something like this. It's asymptotic to that oblique asymptote. It's doing something like this. It's turning around and coming down and being asymptotic along in this direction. So the graph is doing that. Also, I want to see what's happening in this region, so I'll pick another x value. See, I pick an x value of 3. I get a y value of 8. So when x is 3, y is 8. So what that also means is my graph is going to be doing something like this up over here. It's going to be behaving asymptotically up in that region as well, which makes sense because a graph needs to be asymptotic to the oblique asymptote and a vertical asymptote. So that's the shape you're going to get of the graph. If you're not sure of those points, you can pick a few more points and see if your graph matches up. Alright, let's try one more example. See if we can get another unique shape this time around. So our next example is this one right here. Again, the same steps. I will give you a moment to go ahead and give that one a try. We will compare our answers and see if your answer matches up with mine. Good luck. So let's take a look at this problem here. Our first step is always going to go ahead and factor those polynomials. If I factor the top part, I will end up with this expression right here. Negative of x minus 2, 2x minus 1 over x minus 1. What I'll realize from here is there's no common factor, so I don't have any holes in here again. I do have a vertical asymptote. I have a vertical asymptote at x equals 1. So let me go ahead and now graph that. X equals 1. I'm going to go over here really quickly and plot that on. X equals 1. Okay. Next up, you'll realize that because the degree of the numerator is 1 more than the degree of the denominator, we do have an oblique asymptote. We'll work out the oblique asymptote. And our oblique asymptote is going to be y equals negative 2x plus 3. So since that is our oblique asymptote, I'm going to go ahead and graph that as well. So let me do that. Again, we need to graph that linear function, negative 2x plus 3. So start with positive 3. Slope is negative 2. So what I'm going to get is the following right here. Right here, right here, right here. Right, so that's going to be the oblique asymptote that we are working with. I'll leave it as dots. We can make it a dotted line with the ruler. So those are my oblique asymptote and vertical asymptotes. The next part that I need is to figure out the intercepts. So for the intercepts here, I first calculated the y-intercept. I looked at the y-intercept by plugging in x equals 0, which means I got this as my y-intercept, 0, negative 2. For the x-intercept, I plugged in y equals 0, and as a result, I had these 2 points as my x-intercepts. Okay, 2, 0, and 0, negative 5. So let me go ahead and graph these points: 2, 0, 0.50, and 0, negative 2. Let's go back up here. Use a different color to create the graph. So I'm gonna have 2, 0, 0.50, and the other one was 0, negative 2. Just double check that. Yeah, 0, negative 2. Next part is I need to fill in the gaps. I do not have enough information right now just to complete the graph. So my next part is creating a table of values. So here at the bottom I have done a table of values. Okay, here are some of the points that I picked and explain to you why I picked them. I picked negative 10 so that I can see what's happening to the left, a very big negative number, a very big positive number to get a general sense. Then I want to pick points really close to my asymptote. These are the important ones: 0.99 and 1.01, because my asymptote is x equals 1. Then I want to fill in the gaps. I picked some other key points: negative 1, positive 3, and positive 5. Let's plug these points onto our graph and see what kind of shape we end up with this time. Negative 10, 22.9. We know we're going to have a value all the way up here, so I'm going to ignore that. It's going to be off the chart. Positive 10, negative 16.99. I'm going to have a value all the way down here, so I'm going to ignore that. 0.99, negative 99. So right before that asymptote, I'm going to have a negative value down here. 0.99, negative 99, all the way down here. And actually, I just noticed that my y-intercept has been graphed wrong. It should have been 0, positive 2. Right? 0, positive 2. So I had a mistake over here. So hopefully you didn't make that mistake. So I should have the y-intercept up here. This is where we can catch our mistakes. To the right of my asymptote at 1.01, I have a really big positive value, so it's going to be off the chart, but just for reference, I'll put a point up there because I know that's where the graph is headed. Fill in the gaps: negative 1, 4.5, negative 1, 4.5, somewhere up here. 3, negative 2.5, 3, negative 2.5, go over here. 5, negative 6.75, 5, negative 6.75, somewhere over here. Looking at the behavior of that asymptote and the behavior of our graph, this is the function that we're going to end up with. It's going to be asymptotic along that oblique asymptote. It's going to be doing something like this. On that side. On the right hand side, it's going to be passing through this point here, through that intercept, and then asymptotic along that oblique asymptote again. Right, it shouldn't be doing these curves over there, but it's a little bit tricky graphing that with the tablet here, but that's the general shape of the function we should be ending up with. So hopefully you got that and your answer matches up. To finish off the notes for today, we have one last example that's left. What I would like for you to do is to try that next example on your own. We will discuss this example as part of our notes in tomorrow's lesson. Hopefully you enjoyed watching this video. Good luck with your homework. We'll see you in class tomorrow. Thanks. Bye-bye.